There's a lot of modeling that goes into it, but we're projected to be net zero energy. We're producing in the neighborhood of 15,000 kilowatt hours of electricity projected, and that's on different models for this size home. And the appliances and everything that's going into it is very close to what it's predicted to consume.
The first part is kind of three parts to this. Build the best envelope you can build, so reduce your energy load as much as possible. The second is use equipment that can be charged, that can be fed by a renewable source. Now, what we're capable of making here is electricity. We can't make gas, we can't make oil, we can make electricity. So we want to have a system that can use electricity to power heat and cool and hot water and ventilation. And the third part is the supply. So we have a photovoltaic, shorthand PV panels for that. That's an industry that has matured over the last decade or two, and the prices have dropped very substantially. And in most areas there are state and federal subsidies. Right now there's a 30% federal tax incentive for residential photovoltaics.
Yeah, so there's two arrays going in here. We had room on the garage for half of the system, and then the other half we're actually putting on a 2-axis tracker down in the field. So we're going to be able to have a side-by-side comparison, you know, a fixed roof mount versus a 2-axis tracker. See what kind of efficiency gain we get from that tracker.
So a tracker conventionally is, if you looked it up, it would probably say it produces about 30% more energy by facing the sun. But this is an unusual tracker. This tracker is a German product, and it claims to do closer to 40%. We have a great situation here because we have half the system on a garage, exactly half. We can compare the output of the tracking to the non-tracking and see if we actually get 40%.
These are a silicon crystal panel, and these are a black-on-black panel. So a lot of conventional panels you'll see triangles of white, or the frame is silver. So these are very aesthetically pleasing. They're black on black. Once it's installed, it blends right into the roof, and you hardly notice it. So that's, on a nice sunny day in February when it's cold, these can produce, you know, 25% more energy than they're rated for. So, you know, because it's made out of silicon, and as it gets colder, it's more efficient. It generates more electricity. We're not looking to provide any given load at any given point in time. We're going to supply a certain quantity of power over one billing year. So then, you know, it's all based on averages. So in the summer we produce more than we use. We get to use that credit during the winter when we're producing less than we use.
The most we can get out of using electrical energy is to use a ground source heat pump. That will not be the right solution in every condition, but in a very cold climate especially, it's a particularly apt solution.
We're going to drill a well 500 feet deep, and we're going to put a 1.25-inch pipe to the bottom of it and back out. And we're going to circulate in that a alcohol and water solution. The alcohol is to prevent freeze-ups and off-cycles. And Larry's house is going to work a lot like the refrigerator. It's going to take the heat energy out of that circulating water and alcohol and put it into the house through the refrigeration system. The recent improvements in compressor technology and coil technology and fan motor technology all add to the efficiency.
Its efficiency, if you were to have an electric resistance heater and plugged it in and warmed a space, it's 4 times as good as that energy-wise, and on the cooling side, better than virtually any kind of air conditioning that dumps heat into the outside air.
We were told initially, 10 years ago, that it wouldn't work in the Adirondacks. It was too cold a climate, but that's ridiculous. You just drill a 500-foot well, or you put it laterally in the soil, and you use a closed-loop system, and you're just getting heat from the ground on every cycle of the fluid that's in the loop.
But it goes hand in hand. You can't just throw in geothermal. You need the right house for geothermal. If this house leaked a lot and was an old home, I don't know how well it would work.
This project here is kind of a combined system where we're going to be heating the floor with the lower floor with hot water, and that's what all the pipes are behind me. And that's a distribution system called in-floor heating. And then we're going to heat the second floor with air, with a ducted system. For the environment, it means that we'll take 60% less energy than propane. So you'd have to burn that much more propane, which increases the carbon footprint.
So the return on investment is usually around 8 to 10 years if you're just looking at money in and money out on your utility bill. It adds more equity to your home than you have out of pocket. So in a sense, the payback is immediate.
I think it's going to become the predominant heating system. I equate this to it's going to be equal to or bigger than the changeover from coal to fossil fuel.
All winter, we heated this strictly from the water, the geothermal water to water in the slab in the floor. It heated this house basically all winter, and it wasn't even working hard. And that was before the house was completely tight and done.
Jerry Jenkins, who wrote Climate Change in the Adirondacks, was a big proponent of, Larry, you got to monitor the death out of this place because we want to see if it's doing what it promises to do. So in the basement, we have what's called e-monitors, one for each circuit board or each panel, and there's 3 panels. And so we're going to monitor every single circuit. We'll know how much energy we're using on every circuit. We'll also know how much each solar panel is generating, how much each heat pump is using. So we're just going to monitor the heck out of this because that's one thing I think it's part of the educational aspects of this is it working? And if there's parts of it that are not working, why not? And can we make some slight adjustments along the way? And